Howdy class. So today we're going to go over how to count the elements in our set. Right. So we've gone over the basics of what a set is and what unions and intersections. Now we're going to talk about the actual counting the elements in each set. So when we say n of A, like we have here, that means it is the number of elements in A. So for example, if A is 5, 4, and 6, then the number of elements is 3. There are 3 numbers. So let's take a look at this equation here when we take the union of two sets. So first we look at the number of elements that are in A, which would be right here. And then we look at the number of elements in B, right there. And note that we just counted the intersection twice. So because we counted it twice, we have to subtract one of them out. Like so. So let's go ahead and look at this quick example. We have a survey of 100 coffee drinkers. 70 take sugar, 60 take cream, and 50 take both. And we want to know the number that take sugar or cream. And so we got a Venn diagram already done, so let's go ahead and define what A is. So, well, or define the universal set first maybe. U is the set of coffee drinkers surveyed. Okay, and that was 100 was the number in the survey. And now let's define A. So A is any object X such that, well, where X is an element of the universal set such that X takes sugar. And now we define set B. Set B is the element X that is in the universal set, an element of the universal set, such that X takes cream. And now we simply apply the formula. Alright, so we have A is 70, B is 60, and the number that take both is 50. So the number that take sugar or cream would be the union of those two sets, right? The union of those two sets, which is the number in A plus the number in B minus the intersection, like so. Plug in the numbers, and you end up with 80. So there are 80 coffee drinkers that take either sugar or cream or both. Again, or is always going to be an inclusive or. And let's do just kind of a quick note, a quick aside. if I look at A union B, and I take the complement, what am I talking about? Well, keep in mind the complement would be everything outside of here. So that would be the people who take neither cream nor sugar. Basically, it's how many people take their coffee black. So we would say X element of the universal set such that X drinks coffee black. Alright. Moving on. We now carry this over to not just 2 sets, but 3 sets. So here note we have A like we did before. And then we've got B, just like we did before. So note that we're already counting A and B twice. So we gotta make sure we subtract that out. And then we look at C. Now for C, we are counting go and get that in there. Alright, and so note that we're counting A and C twice when we do that. So we got to make sure that we, oh, that's a little too dark. Alright, there we go, that's better. And then we also counted B and C twice. Right there. Now note that there's an area that was subtracted out in the middle that was completely subtracted out. Right, this area that looks kind of black right in there. Right, that was added in 3 times by A, B, and C, and then when we subtracted out the unions, we subtracted it out 3 times. So it's not accounted for right now, so we got to add it back in. Right, I'll just use the gray highlighter for it. Since black would just make it disappear. And so there we've got all the elements accounted for right there. So let's look at this quick example here. We're going to utilize the formula that we have written up or just gone through. So we've got the number of A, union B, union C, right? All the elements that are in the set that we're looking at. So let's go into it here where we have a little bit more space actually. A, B, C, union, union, close. Okay. So in A we've got 5, 1, 3, and 2. Alright, that's set A. And then we add set B. And in B we've got 6, 1, 3, and 4. And now we go to C where we've got these guys there. Like so. Now we subtract out all the intersections. So we had this one here, this one here, actually let's write that over here, and then this one here. And then we have to add back in the final one here. Alright, and so this is kind of set up to illustrate why we have to add that third one back in. And so when we start canceling things out, right, we got 1, 3 minus, and 1, 3 here. 1 plus 3 minus 1 plus 3. And then we've got 3 plus 4 minus 3 plus 4. And then we've got 2 plus 3 minus 2 plus 3. And so note that the 3 is eliminated each time, and everything else is accounted for. So when we simplify this, we end up with plus 2 plus 6 plus 1 plus 5, let's keep it the same order, plus 4 plus 5 plus 3. And so again, note, this is what would have happened if you had simply went through and added each one up without even using the formula. But that's okay, we didn't do it that way, right? We're just trying to illustrate how the formula works. And so when you add all these together, of course, you get 26. And so this concludes 6.2 of the handout. I'll go over the next section in the next video.